This video is about using segment addition to solve for a missing variable. So first we need to talk about what segment addition is. So segment addition means that we're going to take pieces of a line and add them together to equal an entire line. So if B is between AC, then AB plus BC is equal to our whole length, which is AC. So all we're doing is we're adding two pieces or more together to get an entire segment. So let's use segment addition to solve for a variable. So in number one, solve for G and then find AB. So we have two pieces here. We have AB and we have BC. Those added together are going to equal our whole length. So we have 6G plus 14 plus 4G equals 74. Next, we're going to combine our G's. So we have 10G plus 14 equals 74. Then we're going to subtract 14 from both sides, so 10G is equal to 60. Divide both sides by 10, so G is equal to 6. Next, we need to find the length of AB. Well, AB, remember, is 6G plus 14, and now that we know G, we can substitute that value in. So we have 6 times 6 plus 14, which is 36 plus 14, which means AB has a length of 50. Number two, solve for W and then find RS. So again, we know that each piece added together, 9 plus W squared minus 43 equals 7W minus 4 because it's the entire length. Now, we're going to combine like terms here. So I have W squared and I can combine 9 minus 43, which is negative 34, equals 7W minus 4. Whenever you have a W squared or a squared term in general, we need to factor. So everything has to get on the side of the squared. So we're going to subtract 7W and add 4 to both sides. So W squared minus 7W minus 30 is equal to 0. So when I factor, I need two numbers that multiply to negative 30 and add to negative 7. So we have W minus 10 and W plus 3. When I solve, I just need to flip my sign, so W is 10 and W is negative 3. Here's where we have to be careful. If I was to substitute negative 3 into a sign for W, well, negative 7 times negative 3 minus 24 gives us a negative. We can't have a negative side length, so in this case, W is not a solution. We only have W is 10. Once we know and we've confirmed that only one of them works, or in case both, some cases both work, then we're going to find RS. So RS is W squared minus 43. Remember that we know W is 10. So 10 squared minus 43 is 100 minus 43, which means it has a length of 57. Now, number 3 is the same idea. This time there's just 3 pieces that make up our whole length. So we're going to add all 3 pieces together. X plus 3 plus 2x plus 5 plus 5x minus 4 is equal to 12x minus 20. So when we combine like terms, we have x, 2x, and 5x, which gets us 8x. And we have 3 plus 5 minus 4, which gets us plus 4, equals 12x minus 20. When we have variables on both sides, remember you need to get a variable on one side. So I'm going to subtract 8x from both sides. 4 equals 4x minus 20. I need to get my constant on the other side, so I'm going to add 20 to both sides. 24 is equal to 4x. And then divide by 4 on both sides. So x equals 6. Once I know x is 6, I need to go back and get BD. So this entire length represents BD. So I need to substitute into both pieces. So BD is equal to 2 times 6 plus 5 plus 5 times 6 minus 4. which is 12 plus 5 plus 30 minus 4, which gets us a total length of 43. Number 4, B is between AC. So it doesn't give us a picture, but we know that there's 3 points on a line somewhere, and that B is somewhere between A and C. So we have A, B, and C on our segment. Now we can label the pieces we know. So we know that AB is x squared minus 2x, BC is 5x minus 6, and AC is 22. So to solve for x, again, remember that it's piece plus piece equals the whole. So we have 2 or x squared minus 2x plus 5x minus 6 equals 22. So the first thing I'm going to do is combine my like terms of those x's. So I have x squared plus 3x minus 6 equals 22. Because there's a squared term with the x squared, I need to move 22 to the other side so I can factor. So I now have x squared plus 3x minus 28 is equal to 0. So I need to factor what are two numbers that multiply to negative 28 and add to positive 3. So we have x plus 7 and x minus 4 equals 0. Flip your signs, we get x equals negative 7 and x equals 4. Now, if I was to put a negative into the length of BC, 5 times negative 7 is negative 35. Minus 6 is still a negative number. And remember, I can't have a negative side length. So negative 7 is not a solution. If I put 4, though, in, I get a positive number. So I can keep 4 as a solution. Then I need to find BC. So BC is equal to 5x minus 6. So 5 times 4 minus 6 is 20 minus 6, which is 14. Let's look at one more problem to solve. We need to solve x for x and y. So in this problem, it's telling you that FB is 52 and that FL is 78. So when I look at my segment FB, I have 3x plus 8 plus 35 minus 3y equals 52. So first I'm going to combine like terms, so I get 3x minus 3y plus 43 equals 52. Now, because I know there's an x and a y, I'm going to need to move this number to the other side because this problem is going to turn into a system. So this is one equation for my system. The second equation then, 3x plus 8 plus 35 minus 3y plus 2y plus 3y equals 78. Now, when I combine like terms in this one, I get 5x plus 43 equals 78. Now, the nice thing about this is that the negative 3y and the positive 3y canceled out. So this equation only has one variable, so I can actually solve for x right away. So I'm going to subtract 43 from both sides. So 5x is equal to 35, which means that x is 7 when I divide. Once I know x, I can substitute into this equation to get y. So 3 times 7 minus 3y equals 9. 21 minus 3y equals 9. Subtract 21 from both sides, so negative 3y is equal to negative 12. Divide, and y is 4. So my ordered pair would be 7, 4.